So that was the most difficult one, the RLC circuit. And now we're going to back off and look at something a little simpler, the LR circuit. So we're going to put an inductor and a resistor in an AC circuit. And here's what I would like you to try before I run through the answer. Try finding Z for an LR circuit. And then, part B, you should probably find theta as well. That way, whenever you encounter an LR circuit, you could just use these formulas. The only thing I'll say to help you get started, in your phase diagram, this vector would be VR, and this vector would be VL. There will be no VC here, so you should pause the video and give this a shot. Alright, well, just like last time, we're going to be looking for the magnitude of this vector, the V total, basically the combination of VL and VR. And in that case, it's going to be V squared equals, and we're going to think of sliding this over so that it's VL right there, and it's a right triangle. So VR squared plus VL squared. And again, like the last example, at about this step, we'll substitute in for current and resistance. And in this case, current and impedance. Now simplifying the math, we can actually take I squared out of these. What we're left with is R squared plus XL squared. And then I'm going to square root everything. So we would have current times, over here instead of parentheses, we could just put all of this under one square root. R squared plus XL squared. Okay, so this is our new Z for the case of an LR circuit. Now for the phase angle, which would be this guy right here. You're going to see tangent inverse of, and if you're doing SOHCAHTOA here, this would be VL over VR. Substituting, now the i's cancel, so theta is going to be tan inverse of XL over R. Alright, now that we have these for an LR circuit, let's set up a problem and figure out the V and the phase angle for this. For example, let's say we had an inductor with 120 millihenries. It was at 60 hertz. R is 100. Now, basically, you should pause the video and find two things. Basically, find Z, the effective impedance, and then part B, you should find the angle. So give it a shot. Alright, for impedance, you have to figure out XL first, which in this case is going to be 2 pi frequency L. So this is 2 pi, frequency is 60, this would be 120 times 10 to the negative third. Working all that out, you get 45 ohms. Now, overall then, you do the square root of 100, oops, I forgot to put the ohms here, 100 squared plus 45 squared, which, let me calculate that, that's going to end up being 110. So that's the impedance. Alright, for the angle, we're going to just be doing the tan inverse of our XL, which is 45, and dividing that by 100. Okay, working that out, we get an angle of 24 degrees. There we go.